Hi everyone. I thought I'd try to provide some guidance on the ordinary truth tables. And we can start from the homework for chapter 7, 7.3a, and I'm just going to start with the very first problem. This A or B, not A, therefore B. That's the argument. And we click on the arrow and we get the problem, or the truth table that we're supposed to complete. Now when we complete a truth table, we need to put truth values in two places. One is under every logical operator, and the other is under every standalone statement variable. A logical operator is something like the disjunction sign, or the not sign, or the dot for the and, or the arrow for the if-then or material conditional, and the double arrow for the material biconditional. Those are the logical operators, the 5 logical operators that we are working with. And a standalone statement variable is something like a capital letter like B here at the end, which is all by itself. It's not part of any larger statement. It's just the letter B. It's not B, it's not and B, it's not B if then something else. It's all by itself. So that's a standalone statement variable. And those are the only places that you need to put a truth value. So you're going to need a truth value here under the disjunction sign, under the not sign, and under the B at the end, and nowhere else. On this first row, we've got A and B both being true. So when you have a disjunction with both sides, both disjuncts being true, that's going to be true. And what about when you have not A? That's going to be false when A is true. A is true over on the left-hand side, so that's false. And over here, under the B, all you have to do is look at the truth value over to the left, on the left of the dashed vertical line, and it's going to be the same thing there. So you got true, false, true on the first row. Now the textbook can give the impression that that's the way to do it all the way through the truth table, that you go do it across each row. That's not actually the fastest and easiest way to do it, at least for most people. It's not the fastest and easiest because sometimes you can get confused and you're figuring out different things, and you can actually do it a little bit faster and easier if you just go straight down where you're putting in a truth value under something. You can put in all the truth values in a vertical column at the same time. So under A or B, we know that that's a disjunction. We know that a disjunction is true whenever at least one of the disjuncts, one of the things on one side or the other of the disjunction symbol, is true. And so on the second row, that's going to be true. On the third row, it's going to be true again. And then on the fourth row, it's going to be false. That's the only row that it'll be false. Now, over here, where we've got not A, we see to the left of the diagram, under A, we see that A vertically is true, true, false, false. Therefore, not A is going to be false, false, true, true. And that's going to be in general true for a negation sign. A negation sign always reverses the truth value of whatever it is next to. And how about under the B? Under the B, well, we're just going to copy down the same things that are over on the left-hand side. Since B goes true, false, going vertically, B in the conclusion is going to go true, false, true, false. And that's all there is to it. That's the whole truth table. Now we need to check it and see if we got it right. And we did. The truth table is correct. And now we're supposed to figure out if it is valid or not. And if it's not valid, then we're supposed to mark one of the rows to show that it is not, or at least one. There might be more than one. Now, how do you tell from looking at a truth table like this whether it is valid or not? Well, we've covered every possible combination of truth values. That's what this section over here does. It has true, 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 false, false, true, false, false. That's every possible combination because it has both of them being true, both of them being false, the first one being true and the second one being false, and the third one being false and the third row, the first one is false and the second one is true. That's every possible way to arrange the truth values. Now, since we've got that, we know that in a valid argument, you never have all the premises being true and the conclusion being false at the same time. So what we should look for is both the premises being true. That happens only on the third row. See, there's true and true for both premises. And see if the conclusion is false. If the conclusion isn't false when both the premises are true, then it's a valid argument. And you look for every case where both the premises are true. In this example, there's only one place where both the premises are true, namely on the third row. And in that case, the conclusion is true also. So this is a valid argument. There's no possible way to have all the premises true and the conclusion false. And that means this is valid. And as you can see, Logic Tutor agrees. I hope you found that helpful, and I will be back soon with more.